Chapter 22 actually is still proportion problems, but we're going to go ahead and we tacked that onto this 6 weeks since we didn't have room last 6 weeks. Okay, Chapter 22, proportions. These are two proportion tests because let's think about it. Whenever we do an experiment, if say you have some group of people doing the old medicine, then you're going to get the proportion of people that have success with the old medicine. Then you're going to get a separate group of people, and you're going to get the proportion of those people that have success with the second medicine. You will then compare those two proportions. So two proportions are in fact much more common tests to run than just one single proportion, okay? All right, so then what happens is when we do that, we've got to get our z-score and we have to do all of that. The problem is that when we do a z-score, standard deviation has to be a combination of the two standard deviations. How do you combine standard deviations? That Pythagorean theorem of statistics. So this is a picture of the back of the formula chart, and it has the formulas for the combining the two proportions. And the formula for, and if you look closely at this, you can kind of see it's got some stuff going on here with the Pythagorean theorem of statistics happening. Okay, because it's got this, it doesn't exactly say squared, but see, we're multiplying our items together and so on. So this has historically in the past been very mathematically challenging to get right because there's lots of details here. Sometimes you have to use a pooled piece, sometimes you use a separate piece. It becomes very tedious. So because this becomes very tedious, kids get bogged down in the math and lose the meaning of a two proportion hypothesis test. So after I saw kids were struggling with this, I went and I looked at how the AP graders and how the College Board expects you to master this, and they don't expect you to have to necessarily, they want you to do this by hand, but you can get by it by naming what test it is, and then you can do the computing on your calculator. So that's what I'm going to teach you to do and save ourselves some of that hassle. We're going to do just calculator steps. So we're going to learn that today as well. All right, so here we go. When we have two proportions and we're going to be dealing with it, the main difference that we're going to come across is, besides doing it in the calculator, is assumptions and conditions. They have to be done for both groups. And, we don't like doing conditions for one group, much less two. So I'm sorry that you're going to have to do it for both. It is going to be very long and tedious. Therefore, we won't do a lot of these where I make you be thorough and fill those out. But when I do ask you to do it, I need you to, because you need to practice it every once in a while. We'll go through those. The one main difference is this right here. Because we have two separate groups, we have to, this is in addition to the conditions, we have to say that these are independent samples, that a person in one group is not in the other group. So I think that makes sense, that if you're comparing data of two separate groups, you don't want somebody to be in both groups. That's kind of messing up your data. So we have to show that these two groups are independent of each other. And so that's another statement we will make. All right, you still do the sample size and such. So let's move on. This next page that you have is a generic written out two proportion z-test phantoms. Oh my. And so you can see that I would define both of the proportions. You do not have to use P1 and P2. In fact, if I was you, I would use meaningful subscripts, such as if it's the proportion of men that think men are intelligent, you'd be use P with a little M subscript. And the proportion of women that think men are intelligent, and you'd use a W. So use the meaningful subscripts, not just 1 and 2. All right, look at what your null hypothesis is going to be. Our null hypothesis is going to start out with those two proportions being the same. So you're essentially coming into an experiment or coming into a study and saying, those medicines are equally effective until you give me proof otherwise. And then that's what your alternative would say, is that one of them is much more effective or less effective or just is changed, is different than the other. Okay, and so then that's how you do the alternative statement. So look, here's your random for both. We talk about those. We want to talk about them being randomly selected or randomly assigned, and we'll talk about that today when we do our first real problem. Randomly selected or randomly assigned. You do have to see we're using both N's, N for the first group and N for the second group. It says all adults. I meant like is less than the population 1. Population 1, whatever that is. And then this one is less than 10% of population 2. All right, here is that new and improved additional thing you have to show. Random samples are selected independently, or the samples are they are separate from each other. So that's the additional thing. Large enough, we show it for both of them. We will say it's a 2-proportion z-test, and then we get to use the calculator. The calculator will give us a z-score and a p-value. We will then obtain that p-value and compare it to alpha, and then reject or fail to reject, and then make our conclusion. So, that's your phantoms with 2 proportions. Yes, ma'am.
When we do the real stuff, we can do it like that, combine it, say like
yes.
Groups. We don't have to do
I like to combine it. I actually prefer to combine it. The real, I like to combine it instead of doing just 2 separate RALs. Yep. I think that has too much duplication. Okay, so let's do this problem together. Here we go. All right, we're actually going to first start with a problem where you design an experiment. We're going to SRAT me cap, and we're going to do that. You don't have to really do that anymore this chapter, but I want to first do a little SRAT me cap because I want to show you how where the testing comes in the experiment. So here we go. Would being part of a support group that meets regularly help people who are wearing the nicotine patch actually quit smoking? A county health department tries an experiment using several hundred volunteers who were planning to use the patch to help them quit smoking. So you have all these people. They were already planning on, so they were motivated to quit smoking, and they were also planning on using the nicotine patch. So that's the same for everybody. What is the treatment that is different between the 2 groups?
Support.
Yes, we're going to have some of them have a support group and some of them not have a support group. So that's going to end up being our treatment that we are testing to see if that makes a significant difference. So, if you remember our little SRAT me cat, I'm going to sing it to you. So, I don't expect that you remember this, but it is start with the subjects that you have. So, we're going to start with our patch-wearing smokers. Start with the subjects that you have. And then what's the R? Randomly assign them with a big bag. So we're going to write that out here. Randomly assign. SRAT me cap. SRAT me cap. Okay, SRAT me cap. Sorry, I'm trying to, and it's not. Okay. SRAT me cap. Start with patch-wearing smokers. And then randomly assign them with a big bag. SRAT me cap, da-da-da-da-da-da, SRAT me cap, da-da-da-da-da, shake your bag up, shake your bag up. Okay, and then the T is, do you remember what T is? Treatments. State your treatments. Very well. So what is the treatment here that we're talking about in this one? Support group, good. So we're going to have half of our people go to the support group. And then the other half is going to do what? No support group. Good. Treatments. State your treatments. Very well. Okay. And then measure each subject's response to them. So ME is measure each smoker's success of quitting, I guess, smoking or something. And this will be like, you know, your yes, no. Did they quit smoking? Okay, there's that. Okay, strap me cap, shake your bag up, strap me cap, shake your bag up. Do you remember what the cap is? Compare your average or your proportion. That's right, so that's where we go like that. Compare your average. So what are we comparing here, though? Good. Proportion. Yes. Compare the proportion of each group's success in quitting smoking. Okay, so that's just a diagram of what's going on. So we're comparing that. And where in this diagram does a 2 proportion z-test come into play? What of this entire diagram does a 2 proportion z-test do? Yes. It helps us to mathematically compare the 2 proportions and see if there is a statistically significant difference where we can say, yes, this is proof that one of them is statistically significant and much different than the other.
I thought at the end of strap me cap we were supposed to go to...
Oh yeah, strap me capped. I put a T on the end, right. To see if, yeah, it was that thing, maybe, yeah. Remember, we put a T on the end of strap me capped to see if support group significantly helps. Yeah. So remind me that whenever we get those. All right. All right. So here we go. Let's now go ahead and take a look at the suggested study. Here it is. Subjects were randomly divided into 2 groups. Check, that's what we did. People in group 1 were given the patch and attended weekly discussion meetings with counselors and others trying to quit. Okay, we did that. People in group 2 also used the patch but did not participate in the counseling group. Okay, good job, we did that. After 6 months. So by the way, here is the p-hat for group 1. After 6 months, 46 of the 143 smokers stopped smoking, were successful. Here is the sample proportion for group 2. And 30 out of the 151 smokers in group 2 had successfully stopped smoking. Do these results suggest that support groups could be an effective way to help people stop smoking? Complete a 2 proportion z-test. Now, those proportions are different. Yes, they are. But does that mean that it's significantly different enough to say, I reject that they're the same and I conclude there is a real difference? Or is it just due to sampling variability? Well, we need to do a test and see. So go to the next page. Here we go. So we have to define 2 population parameters. What letter do you want to use for the 2 groups?
PS and PP.
Okay, I'm going to do PS, and then I'm going to do P with a little N for no. So S is for support group, and N is for no support group. Okay, here we go. How do we write this out? The first word is not probability. The first word is proportion of, and what would be our denominator here? Okay, patch using smokers. Got it? Patch using smokers. Who attend support group. Yes, very good. Who attend a support group. Okay, so that's the denominator. the denominator is, we're not finished with this yet.
Okay.
Yeah, we're just at the denominator. This isn't finished yet. Proportion of patch-using smokers who attend a support group, that's the denominator. Now what's the numerator? Who successfully quit smoking. That's the numerator. Okay, again, I'll read it. Proportion of patch-using smokers who attend a support group. That's where my S came from. Who successfully quit smoking. All right, I'm going to do this in a different color just so it's easier to see. P, and I'm going to use the little N. And this is going to be the proportion of what?
Patch-using smokers who did not.
Okay, good. Proportion of patch-using smokers who do not attend a support group and quit smoking. Patch-using smokers who do not attend a support group. What? Yes. These are present tense, by the way. Who do not, because I'm making an inference about the whole population of them, not just the ones in the sample. Who do not attend a support group. Who successfully quit smoking. That's the numerator. Successfully quit smoking. All right. So our null hypothesis, what would we start off saying about these two groups? They are the same. They have the same success rate. So the proportion of smokers and proportion of non-smokers is the same. Success rate. Have the same success rate. Okay, what would my alternative be?
S is greater than
The proportion of smokers that use the support group is more successful than the proportion of smokers who do not use a support group. Okay, very good. That's the hypothesis statements. Now, here comes our assumptions. These are going to be very tedious. I'm going to do these once with you very thoroughly, and then on your homework, out of the two phantoms, I will ask you to just do one of them very well. Okay, instead of making you rush through two of them, I want one of them very good quality. So here we go. What's our first condition? Random. All right. Now let's talk about this. I want to add a little component to random where if we want to pay attention to if this is a study or if this is an experiment. If it is a study, then we're just randomly selecting from the population and observing, if it's an observational study. If it's an experiment, then we don't just randomly select in an experiment. What do we do in an experiment? We randomly assign to the treatment groups so you can claim a cause and effect. So we have to. So what happened in this case on this problem?
randomly divided into two.
It says in the problem randomly divided into two groups. So we're going to say that I'm going to write random. And then I'm going to put, it was stated that all such smokers are randomly assigned to either the support or no support group. To the support or the no support group. Okay? There was a summer about 3 years ago where if the people did not say that the subjects were randomly assigned, then they got 0 credit for all of their conditions on that problem. Okay, so I'm going to start as we go through problems having us notice, is this an observational study or is this an experiment? And we'll start using a randomly assigned or randomly selected. Okay, so what's next?
Independent.
independent. N is less than 10% of the population. So I have to do this for both of them. The first N, go back and look. The first group, the one with the support, how many? 143 is the size of the sample, and I'm going to say it is less than 10% of all such smokers. When I say such, that means ones that are trying to quit and use a nicotine patch, who attend a support group.
Could the also smokers cover that?
Yeah.
No, because I have to do the next one, and I have to say 151 is less than 10% of all such smokers who do not attend a support group. I need to really clarify the difference between those all such smokers. Okay, the next group is 151. That was the size of that one, is less than 10% of all such smokers who do not attend a support group. If you just put all such smokers on both of those, then it's not clear what the difference is between those two populations. Okay, do you understand what I'm saying on that now? Okay, that's why it was necessary to include that. Just set it on the floor, okay?
So on random, it will always be randomly assigned or randomly
Selected.
Okay, just double check.
Okay, now we have something new that goes with this because we have two different groups. This is new. Anybody remember what it is? Okay, good. These two samples are independent of each other.
Can we say that they are, or do we use something?
Either, because we're kind of laying out the assumptions that have to occur for the conditions to be met. Two samples are independent of each other.
So we'll always put that?
Yes, whenever you have two groups, you always have to put, when multiple groups, you always have to say that they're independent of each other. Do you know that I did bad earlier in the year when we did, actually right after Christmas, whenever we did our 50 M&Ms. And I had you count the proportion of blue ones, and I have you count the proportion of orange ones. You counted them both in the same sample. So that was not good because those actually proportions were connected together. If everybody tended to be high on the blues, then probably what were you on the oranges? Low. Yes. See, so in hindsight, I've over the years realized that was not proper. I go ahead and I leave that in there because it's a good discussion to have with you guys at this point. Okay? All right. Next. What's the last one? Large enough. Okay, so we have to do large enough for both sets. So think about this. I'm going to put S for the support group. Okay, so at least 10, so N times P. So that's going to be 143 times, is there a P, a true P? There's not. I have a P hat. The P hat is 46 over 143, which, hello people, guess what that equals? 46. And that is greater than or equal to 10. And I have been counting people's problems wrong lately. I have noticed a few of these people putting a 10% right there. They put 0.10 there. That's a no-no. It's 46 is greater than or equal to 10 items, not 0.10. Okay? All right. If there are 46 successes, then how many failures are there?
90.
Yep. Because if you think about it, 143 minus 46 is 97. That is greater than or equal to 10. All right, so that's the support group. Now I have the no support group.
151.
That was 151. And that's N times P, which is 30 over 151. So magically that equals 30, which is greater than or equal to 10. If there are 30 successes, then how many non-successes are there?
21.
Okay, so I've got to find out the failures. There's 121 failures. Okay, so that means there was 4 statements you had to write there, not just 2. Because you had 2 for one group and 2 for the other group. And we conclude this by saying, of course, normal model applies. Okay, so that was very, very painful. Okay, now the good thing is that when it comes to the test statistic, you get to do it in the calculator, so that comes in ease of calculation. Let's go, what's the name, the formula, or the test?
2 proportions.
Good. 2 proportion Z test. Remember whenever you guys used to be like, what the heck is this 1 proportion Z interval mean? Well, now you're starting to get the picture that we have these menu of items and we are on 2 proportion Z test. All right, so now let's go to the calculator. So I'm going to come over here to the side. I won't have an actual picture of a calculator, and I'm going to tell you what you're going to see on your calculator. You need to go in your calculator, second, wrong, that's not right, stat. You're going to go stat over to tests. Oh, and then so if you don't have a calculator, go get one. Then you have a whole menu of items. Number 5 is interesting. What does number 5 say?
1 proportion Z test.
Oh, 1 proportion Z test? Oh, you mean you could have been doing all of those ones that we've just done by hand? Yes. Now, let me tell you something. Hey, I'm not one to make you do work if there's not a reason for it. I actually will continue to have you do these 1 proportion Z tests by hand because they are simple to calculate and you have to maintain understanding the process, because if you do not use it, then you will lose it. So I will have you continue to do 1 proportion Z tests by hand, but I will let you take these ones that are much more complicated and allow you to use the calculator for them. Number 6 is a 2 proportion Z test. So hit that button. Number 6, that's what we want to do, a 2 proportion Z test. When you do that, here's what shows up. You get X1, N1. Oops, that's wrong. X1, okay, and I think, is it a lowercase n or capital? Yeah. N1, and then X2, N2, and then it gives you like P1 not equal to P2. Okay, and we'll talk about that in a second. All right, so a couple things. Okay, listen up. This is important. This right here is a number of successes. This is not a percent, and it will be not a decimal number. If you put in a percent or a decimal number right there for X1, you will get a calculator error. Okay? All right, but this problem has a whole number of successes. How many successes did the group 1 have? 46 should be put right there. And then 143 is the number in the sample. Group 2 had 30 successes and 151 in the group. Now, let's take a look at this next line. It's what your alternative says. It either says P1 is not equal to P2, or it says P1 is less than P2. Is that the next one that shows up? Or greater than P2. That's what's in your calculator. Which one do we want to highlight? Okay, so highlight that one in your calculator. And then you go down and you hit calculate. Okay, so what it shows you, the top 2 things, well, actually the first one, it says P1 is greater than P2. It gives you the z-score of 2.40707 or something like that. Okay, then it says P equals 0.008, and then all those things. And then it gives you the P hat of 1, P hat of 2. It gets those from actually dividing out 46 by 143. It took 46 divided by 143, and that's what that is. It took 30 divided by 151, and that's what that is. And there's a regular old solid P. That is a pooled P. So do you see how many P's there are? I do not like that. And in fact, do you see this one right here? That one is the one that is your P value. This is the one that is your P value. And then you also have to write down the z-score. So those are the two items that you clue into and target to write down on your Phantoms model. Okay, so here we go. Under here, for test statistic, instead of doing all the mathematical work, because those conditions were god-awful, we get to just write z equals 2.41. And I do not want you to write p equals. There are too many p's to not be clear. P value equals 0.008. People have been getting all the different p's mixed up, and I do not want us to do that. So now, obtain a p-value and compare to alpha. I'm going to write this line out, and there is no shorter way to write it. You include every single word, or else it is wrong. If you do not write p-value equals 0.008, which is less than alpha equals, they didn't give me one, so I'm going to use the default 0.05. There is no other way to write that. If you just put p equals, I will mark it wrong, because there's just too many proportions going around. All right, so based on that, what would we do? We have a p-value. It is low. Reject HO. Okay? So now, conclusion. How do we start it? Since 0.008 is less than 0.05, I reject HO. Okay? That one is short and sweet. The next one is going to now be longer, and so I'm going to put this one in a different color so it stands out. All right, the first one was about HO. Therefore, this one is about evidence of HA. You have or you do not have evidence of HA. That's how this should always start. So do we have evidence of HA? Yes.
There is evidence.
Okay. There is evidence, and you could put to suggest if you want to. There is evidence that, to suggest that. Okay. Now, let's go back up here and look at it. I'm going to say this in words. Okay? It's not going to be pretty, but it's going to make a complete, final, clear statement. So let's do that. Here we go. There is evidence that the proportion of all such, how about support group smokers? That's about as quick as I can say it. There is evidence that all such support group smokers has, not past tense, present tense, has a, should that be have? Smokers have. All such, oops, that the proportion has a higher success rate than all such non-support group smokers. Okay, whew, that is a complete two-proportion z-test. I mean, this is huge. I want you to think about it. Was that a lot of work? Yes. Hey, but listen, you are making a decision about if a medicine works or not. You are making a decision about whether you should get funding or not for a whole entire project. You are making decisions that are going to affect big-time stuff. So it better be a lot of work to make that conclusion. All right. Tomorrow we will do the panic model. So that is not today. Here goes your assignment. Your assignment is to do the Phantoms model for problem number 1. Do not do this panic model yet. The panic model is tomorrow. And then you will do the phantoms model for problem number 2 on the proportion of men versus the proportion of women who think men are intelligent. Now, I do actually have to talk to you about a potential calculator problem. So let's address that first, because I do not want you to get to doing this problem in your calculator and get a calculator error. All right, let's look at problem number 1. So you're just doing part 1 on both problems. Part 1 on both problems. First problem is about contamination of chicken. They purchased, these people who did this observational study. We're not assigning them to a treatment group. We're just observing. We're going to randomly select Jenny O chicken and randomly select store brand chicken and see if which one has a higher proportion, and if it's significantly higher, of contaminated chicken. Okay, so here we go. The proportion of Jenny O one has 33% of the 75 Jenny O packages that had contamination. The store brand had 45% of the 75. So here's my point. I want to go to your calculator. When you go stat over to test and you do a 2 proportion z-test, let's have a little discussion about x1 n1 and x2 n2.
X1's going to be 0.33 times 75.
Yes. The way you get this is 33% of 75, and if you hit enter, that gives you 24.75. Is that allowed?
No.
No, you cannot have a percent or a decimal. All right, so you cannot do that. You round appropriately, because that means they rounded 33%. It was probably 33 1/3, and they rounded down to 33%. So you would put in a 25 for that x1 out of 75 for your n. Okay, how would you do the second group? 0.45 times 75 is 33.75, and you cannot have 33 3/4 packages that are contaminated. So you have to round appropriately to 34 out of 75, okay? Otherwise, you will get an error because you have to have a whole number of successes. Yes?
Which one of these really thoroughly
Okay, good. Thank you. So, hey, guys, remember I told you only have to get full real on one of them? I want you to get full, high quality real on this first problem. We will do real on problem 2 tomorrow. Okay? All right, so get full real on number 1.